Hello classmates, welcome to yet another video. So today we'll be working on paper 2, measurement, how to calculate the height. So we are going to be learning how to calculate the height today. And we have a question here from a previous question paper, and it reads as follows. More water must be taken to the refreshment stations. The water will be transported in cylindrical buckets with lids, with a maximum capacity of 20 liters of water. So there is the picture of a bucket, the 20-liter capacity bucket with a lid, and they have also shown us the top view of the buckets placed in a solid rectangular pallet. And we've been told that the outside diameter of the bucket is 31.2 centimeters. And another more important information right there says that, note, bucket walls are 2 millimeters thick. So this one means that the bucket walls, the plastic that they have used to make the bucket, is 2 millimeters thick. So the question says, determine the maximum height in centimeters of the water in the bucket if the outside diameter is 31.2 centimeters. You may use the formula. There is the formula to calculate volume of a cylinder, which says pi multiplied by radius squared multiplied by height. And they have told you that pi equals to 3.142 and 1 liter equals to 1000 cubic centimeters. Okay, so as you can see on the question, we have been asked to calculate the height of the water that will be inside the bucket. As you can see on the dimensions, we have been given 20 liters, which is the capacity of the bucket. We've been given the outside diameter of the bucket, which is 31.2 centimeters. And we have also been given the thickness of the walls of the bucket, which are 2 millimeters. So what we have to do now is that we have to determine the inside diameter of the bucket, because remember the question wants us to calculate the height of the water that will be inside the bucket. So since we've been told that we have to calculate the height of the water that will be inside the bucket, and not the height of the bucket, but the height of the water that will be inside the bucket, that means that we are going to have to use the inner diameter of the bucket. We are not going to use the outside diameter, because the water will be inside the bucket and not outside the bucket. So that means that we have to determine the inside diameter of the bucket, and this is how we're going to do it. So since we've been told, since we've been given the thickness of the bucket walls, and we've been told that they are 2 millimeters thick, we have to subtract the thickness of the bucket walls from the outside diameter, and that will give us the inside diameter. But before we can do that, we have to take the thickness of the buckets, which have been given to us in millimeters, and convert them to centimeters, so that we'll be able to subtract them from the centimeters. So this is how we're going to do it. We're going to start by converting 2 millimeters, which is the thickness of the bucket walls. We're converting it to centimeters, and we are going to divide it by 10. So it's 2 divided by 10. That gives us 0.2 centimeters. So this is the thickness of the bucket walls. They are 0.2 centimeters thick. So now we're going to take the outside diameter, which is 31.2 centimeters, and subtract two thicknesses, two walls, which is the wall that is on the bottom of the bucket and the one that is around the bucket. We are going to say 2 walls, 2 bucket walls, multiplied by the thickness of the bucket wall, which is 0.2 centimeters. So the reason why I'm multiplying by 2 here, it's because 0.2 centimeters is the thickness of just a single wall, bucket wall, and we have 2 holes, which is the one that is on the bottom of the bucket and the one that is around the bucket. So we are subtracting them in order to find the inside diameter. So it's 31.2 centimeters minus 2 multiplied by 0.2. And that gives us 30.8 centimeters. So this is our inner diameter. This is the diameter that we are going to use in order to calculate our answer. So now that we are done with the diameter, we are going to calculate to find the volume of the bucket. So we've been given the capacity here, and as you can see, the capacity is 20 liters. That is the capacity of the bucket. And when you look at the information given to us there, we have been given the conversions from converting from liters to cubic centimeters. We've been told that 1 liter equals to 1000 cubic centimeters, and we have 20 liters of capacity. So we are going to do what? We are going to take our capacity, which is 20 liters, and multiply it by 1000 cubic centimeters. I'm sure they've told us that 1 liter equals to 1000 cubic centimeters. So we are trying to find the volume of the bucket in cubic centimeters. So we're going to take the 20 liters that has been given to us and multiply it by 1000 cubic centimeters. So that is going to be 20,000 centimeters cubed. So this is our volume. This is the volume of the bucket. So now we have the volume of the bucket, and we also have the inner diameter of the bucket. So I think we can now go and calculate the height of the water that will be inside the bucket. So when we go back to the question, you can see that they have given us the formula to calculate the volume of a cylinder. And I know that we already have the volume of the bucket, and it is 20,000 cubic centimeters. But we are going to use the volume to calculate the height. So the formula says that volume equals to pi multiplied by radius squared multiplied by height, right? So now we are going to substitute the formula. We are going to put the values that we have where they're supposed to go. So do we have the volume? Yes, we do have the volume of the bucket, and it is equal to 20,000 cubic centimeters. We calculated it before. It is 20,000 cubic centimeters. It is the volume of the bucket equals to pi. When you go back to the question, they have told you that pi equals to 3,142, right? So where they've put pi, we are going to write 3,142, right? Multiply by radius square. So do we have the radius? No, we do not have the radius, but instead we have the diameter. And you all know that when you calculate the radius, you take the diameter and divide it by 2. So we're going to put brackets here and write our diameter, which is 30.8 centimeters, and divide it by 2. So this one will give us the radius of the bucket, and then put square, multiply by height. So on the height, we're not going to write anything because we do not know the height of the bucket. It is what we are trying to figure out, right? So now we're going to go forward. We're going to start with the brackets, as Bodmer says, brackets first, right? So we're just going to copy this one down. 20,000 cubic centimeters equals to 3,142 multiply by, and then now we're going to work on the brackets. So it's 30.8 divided by 2. So that gives us 15.4 centimeters, and then square multiply by height. Okay, and then we are still going to write this one down. 20,000 cubic centimeters equals to, and then you can just press the whole thing on your calculator. You can just say 3,142 multiplied by 15.4 squared, and that gives us a total of 745,15672. Please do not round it up, do not round it down, just write it as it is. Multiply by height, so it is going to be 745.15672 0.15672 height, right? So we want to figure out the value of height, the value of age. So on this side of the equation, we have to be left with only the height. So we have to remove this number, and the only way to remove it is if we divide it by the number 745,15672. And because we have divided with this number on the side, that means that we also have to divide with the same number on the other side, because they say that what you do on the right hand side, you also have to do on the left hand side. So even on this side, we're going to divide by 745,15672, right? So we're going to divide 20,000. We're going to click this on the calculator. It's 20,000 divided by 745,15672. That gives us 26,839,99146 equals to this one divided by this one. So these two cancels each other. This one cancels this one, and we're only left with age on the side, right? So that means that the value of age equals to 26,839,99146, right? We can round it and it is going to be 26,84 centimeters, because remember, we've been told that our answer should be in centimeters. So this means that the height of the water that will be inside the bucket equals to 26,84 centimeters. And this is how we calculate the height when we've been given the capacity or the volume. We use capacity or the volume in order to find out the height of the figure that we've been given. Okay, and we also have another example here. Please, before I write the answer to this question, please pause the video and attempt to answer the question first, just to be sure that you understood the previous example. So the question says, Miss Bagley's son owns a small bakery. She uses a cylindrical baking pan as shown below. So there is the picture of the baking pan that Mrs. Bagley's use. And they have also given us the dimensions of the baking pan. We have been given the diameter, which is 280 millimeters, but we have not been given the height. So it is obvious that we are going to have to calculate the height. So another information there says, other information, a cylindrical baking pan has 3,079.16 cubic centimeters capacity, and they also say that the oven must be preheated at 430 degrees Fahrenheit before placing the baking pans inside the stove. Okay, so the question says, determine in centimeters the height of the cylindrical baking pan. You may use the formula, and you have been given the formula to calculate the volume of a cylindrical baking pan, and the formula says 3,142, which is pi, multiplied by radius squared multiplied by height. It is similar to the one that we used in the previous example. So I think that most of you already have an idea in terms of what you are going to have to do from here. So first thing first, let's see if our dimensions have been given in the unit of measurement that our answer have to be in. So we have been given the diameter in millimeters, and the question says that our answer should be written in centimeters, and also the capacity of the baking pan has also been given to us in centimeters. So it is pretty much clear that we have to convert our diameter from millimeters to centimeters. So we are going to take the diameter of the baking pan, which is 280 millimeters, and convert it to centimeters. So we are going to divide it by 10. So it's 28 divided by, it's 280, sorry, 280 divided by 10. It gives us 28 centimeters. So this is the diameter of the baking pan, in centimeters. So we can just calculate the radius just on the spot so that we don't have to do it on the formula right there. like we did in the previous example. So we're just going to take the diameter of the baking pan, which is 28 centimeters, and divide it by 2 in order to get the radius. So 28 divided by 2 gives us 14. So that means that the radius of the baking pan equals to 14 centimeters. All right, so the next step is where we have to use the formula. So in this example, we're not going to convert our capacity to cubic centimeters because it has already been given to us in cubic centimeters. So we are just going to use it as it is. So we take the formula which says volume. This is the formula that they said that we can use to find the answer. Volume equals to 3,142 multiplied by radius squared multiplied by height, right? So now let's substitute on the formula. So on the volume, we are going to write the capacity that has been given to us. I know that the formula talks about the volume, but one thing you should know is that the volume and the capacity are always equal, right? So they might have different definitions or whatever, but in terms of size, the volume is always equal to the capacity. So we're going to take the capacity and put it on the volume here, and our capacity is 3079.16 equals to 3,142, which is the pi, multiply by, and then into brackets our radius. Remember that we have already calculated the radius on the previous method that we used, and it was 28 centimeters was our diameter, and we divided by 2. It gave us 14 centimeters, which is our radius. So we're going to put 14 here, square, multiply by h for height, which is what we are trying to determine. So we're just going to rewrite this one, 3079.16 equals to, and then you're going to click these two on your calculators. So it's 3,142 multiplied by 14 squared, and that gives us 615,832 h for height, right? So we have to be left with only the h on the side. This means that we have to divide both sides by 615,832. So divide the sides by 615,832, and because we have divided with this number on the side, that means that we also have to divide with it on the other side as well. So we are also going to divide the side by 615,832, right? So let's click that on the calculator. 3079.16 divided by 615.832. That gives us 5, right? 5 equals 2, and then these ones cancels each other, and we're only left with h. So that means that h equals to 5 centimeters. So that means that the height of our baking pan equals to 5 centimeters. So this is how we work with the height, and this is how we calculate the height. So thank you so much guys for watching the video. Thank you so much for the likes and the subscriptions as well. I'm very much happy that my videos are making a difference and you guys are learning a lot from my videos. I really appreciate it. Please do not forget to study smart, not hard. May goodness and grace lead you to the great heights of success. Thank you guys for watching this video. I really hope it was helpful. Thank you so much for the subscriptions and the likes as well. I really appreciate it, guys. I'm so happy that my videos are making a difference and you guys are learning a lot from my videos. Thank you so much. Please do not forget to study smart, not hard. May goodness and grace lead you to the great heights of success.